My talk is called Resilient Testing at Scale Using Redis Queues to Manage Concurrency, which now I say it aloud is kind of a mouthful. I'm a software tester. My name is Aaron Evans. I work for a company called Slabs. Any other people with software testing experience in the room? One or two? All right. Okay, 3, 4. All right. So I'll go ahead and start. What I'm going to talk about specifically is test automation with Selenium using Slabs. Anyone familiar with Selenium as a product? Okay, so quite a few, more than admit to testing. So for those who don't know, Selenium is an automation framework that allows you to automate the browser. It has a client-server architecture called WebDriver, and also there's Appium for testing mobile apps. And Slabs provides a Selenium infrastructure, provides browsers and devices for users to test on. And so that's what we do. And specifically, I'm going to talk about how to implement a queue in Redis to manage concurrency. When you're running tests in parallel across multiple teams, you need to be able to test concurrently and not step on each other's toes, not exceed your concurrency. And I'm new to Redis, actually, myself. And my first actual product developing this was to build this queue for concurrency. And so I'm going to kind of take you through my use case as a case study and talk about the basic Redis data types and how to use each of them in this situation, as well as talk about PubSub, publish and subscribe for notification, and then about how I use Redis JSON to store the test results, and Redis Search for analyzing and finding historical data. And if I have time, I'll talk about how I'd like to use machine learning and AI to predict test failures and improve performance. So a little bit about me. Like I said, my name's Aaron Evans. I've been testing software for about 20 years. I'm an accidental software tester. I don't know anyone who's actually said, "Mom, when I grow up, I want to be a tester or a firefighter," or something like that, right? It's something you kind of stumble into, at least until recently. But after several years testing, I'd had it. I was sick of sitting in a cubicle and doing a bunch of repetitive steps and not being appreciated. So I burned out. I moved to Fiji, said I was going to go be a beach bum, and but then I came back because I'd been sailing around the island, said I want a sailboat, and so I came back to earn some money to get a boat. Ended up getting married instead. Moved to Ecuador, and since I didn't have a job down there, I did some consulting. Got involved with open source. My first real exposure to Selenium back around 2006, 2007 timeframe. Worked on the Mozilla project, doing some testing with that. Mozilla, of course, makes Firefox, and kind of fell back in love with software development and testing and open source tools. Anyway, looks like you guys already read my bio, so I'll go ahead and skip ahead. But I do live in Montana. I don't live in a yurt, but I built a yurt, and when summer comes, since I didn't get the wood stove installed, it's too cold in the winter there to stay in the yurt. Anyway, so Slabs, as I said, provides test infrastructure, thousands of browsers and mobile devices to test on. It was created by Jason Huggins, who was the original author of Selenium. And a lot of great people worked to build the infrastructure there. It's essentially a private cloud with a Selenium grid that thousands of different customers connect to and run millions of tests a day on, and and they have a nice UI dashboard and reporting and so forth. But the real challenge comes when the large users, companies who are running tens of thousands or even millions of tests a day, want to be able to manage their testing and concurrency. As a solution architect at Slabs, my job is to talk to their big customers and figure out what their testing problems are, often around parallelization or network optimization. And I'll work with one team at a time. And a company might have team A, wants to run 100 tests in parallel. Say the company has purchased 100 concurrent tests. Team A has 100 tests they want to run, and team B has 100 tests they want to run. If they both run all their tests, well, then some of those tests are going to end up waiting. Now, Sauce Labs has a kind of queue. It's not really a queue. It's more of a buffer that it waits 10 minutes for your test to start before giving up and saying, sorry, this line is busy, call back later. Anyway, so one customer approached me and said, look, our teams need to be able to coordinate because we want to maximize our tests. A lot of people try and divvy up their concurrency to make it so that teams don't step on each other's toes. So team A might be assigned 50, team B might be assigned 30, and team C might be assigned 20 concurrent sessions. And that way, they never exceed 100 total. The problem with that is no one's getting optimal use, right? If team A isn't using their sessions, team B could be running all 100 tests at the same time, or team C, vice versa. So they need a way for the teams to coordinate. And I thought about it for a bit, and I said, well, all you need to do is coordinate, right? You can just create a tally, and on some central server, just check in and check out. So if you have 100 concurrency and a test starts, you subtract 1 from that concurrency. And then when the test completes, you add 1. As long as you keep that tally and all the users in your organization are going through that endpoint, then you'll make sure you never exceed concurrency, and you can always go up to your maximum. And they said, great, can you show us how to do that? And I said, well, let me think about it. And I came back with this solution. So I guess I kind of talked about this here. The idea is that you create this pool of sessions, much like a database connection pool, right? You create a DB connection pool to make sure that, that you don't overwhelm the database. So you might create 10 or however many connections in your pool that provide resiliency and provide a way to distribute your requests among the different workers. Now you've got to worry about things like network load and process load, but the nice thing about doing this is you can distribute it. It's not a single monolithic database, but it's the same sort of pattern, and it's like checking in and out books from the library. You can say, I want to go check out 10 books from the library, and then when you return them, someone else can use them. Only we're talking about browsers instead of books, and that it can be any browser or any mobile device. And then another analogy is that it's like a ledger that you write tests that move from pending to active to complete. And the last part is you want to be able to store the test data in Redis for future use. So Sauce Labs provides a simple way to manage this, but it's not complete. You can make an API call and say, this is how many sessions I'm using right now, or my organization and my various teams. So that gives you something, a general rule, but the problem is you've either got to keep querying the endpoint, and when you do, you have no way of guaranteeing that someone else can sneak up behind you. It's a race condition. If you've got many teams, someone might grab sessions by starting a pool of tests before you can start yours. So I thought about how to do this. I started learning programming back with Perl and PHP back in the days, and so my first thing was, well, I'll just create a very simple table in MySQL. But I don't want to try and maintain that, and I don't want to give that as, even with a Docker container, as something for customers to use. And then my next step was, well, if I'm just keeping a tally, a simple key value store, like Memcache will work. And then I thought, well, if I'm throwing a bunch of data in there, a NoSQL database like MongoDB works great. And then I thought, well, for some of these fuddy-duddy enterprises who can't install anything, we're talking everything's legacy, they need 3 signatures to install software on their laptop. But they probably have an NFS mount or Microsoft equivalent. I don't know what Microsoft calls it, but in Linux we call it SMB, right? You could even do that, right? You could have a file that stores it, or you could build a whole web service and run it. But Redis, I think, really hits a sweet spot. Number one, it's going to be faster than a shared network, easier to set up than a web service or a SQL database. And it has a really simple API with clients available. Just about every language has a simple Redis client. except for client-side JavaScript, which I understand there's some difficulties in doing that, but you can put WebDis in front of that. Anyway, and it's a nice middle ground between a simple key value store like Memcache and a NoSQL database, which is full of semi-structured, essentially JSON-style data. Like I said, I didn't want the hassle of setting anything up, and the clincher for me was I searched for free Redis, and Redis Slabs came up, and so I signed up for the 30 meg account, whatever it is, and got going. And mainly I wanted to learn something new. That's why I chose Redis. So I'm going to walk through the implementation, and this is part case study, and it's going to be part tutorial. So if you're really experienced with Redis, you might laugh at my simple examples, but it really is that easy to implement. If you're new and you want to explore some of the uses of these data types, then you might find something interesting here. So first case, like I said, just keep track with a simple counter, right? How many available sessions do you have? A string handles this well, just a string, or as someone said yesterday, they like to call it a scalar instead of a string, because it's not really just a string. It can also have a numeric value. And when the value is numeric, you can, 1, 2, 7.5, you can increase or decrease it with the increment and decrement commands. So each time a test session starts, you subtract 1 from the counter of available sessions, and when the test completes, you add 1 to the counter. And the way to handle this is to just, in your test framework, just have a little factory in front of your test initialization that either your base class or factory or whatever calls this counter each time a test starts and finishes. Which works fine as long as everyone uses it. If someone goes rogue and connects on their own, well, that's an administrative problem that I can't solve. So I've got kind of like a screen capture session here to mimic so that you guys don't have to see my typos. But if you really want to, I can bring up a terminal and type it out. So the idea is that first thing, I create available sessions, and I set the initial value to 100. That's the concurrency available to this particular organization. I can call get available sessions and get the number. Right now, since nothing's been added, there's 100. Next thing I do is I start a test. I call decrement available sessions, and you see it returns an integer, 99. So there's 99 sessions left. And next thing, the test completes. I call increment available sessions. There's 100 tests available again. You can also decrease by an amount. So in this case, I decrement available sessions by 50. It returns 50. There's 50 tests left, or 50 sessions left for other people to use. Increment by available sessions, 25. So essentially, it's returning 25, and you have 75 available sessions left. Really simple use case, and it didn't take long to implement, so I said, let's go a little bit further than that. I've got one more command. Get set performs an atomic get and then a set. I kind of wish there was a set get, but it returns the value anyway. Get set will do a get. It will return the value, and it will set or change the value all in one atomic operation to make sure that nothing gets in the way. For instance, if you're getting and setting as separate commands, someone else could get in, even if you pipeline it. So here I'm increasing the total sessions to 150, and it returns, by the way, there's 75 currently or there were 75 sessions available, so you subtract 75 from 100. There's 25 concurrent sessions being used. You need to handle that on your own, though. Okay, so I decided to go to the next level. Well, I could almost as easily, and actually with fewer commands, just create a list and get the length of the list. So what I did is every time a test starts, I add the test session ID to the list. And then at the end of the test session, I remove that session ID from the list when it completes. It accomplishes the same thing. Then I just do a get length of the active sessions. And that way you don't have to do any math to figure out what's going on. And then lastly, you can trim, use ltrim to make sure that your total available or active sessions stays within your bounds, just as kind of a cleanup method. So again, my sudo terminal. And I decided I would just do Redis CLI commands because it's easier than translating from one language to another. You probably don't want to see my Java code, which by the way isn't compiling. Hopefully I'll have a working system that's open source that I've been able to extract from the prototype, and other people will be able to use it. But that'll probably be more interested to people testing with Selenium, either with a local grid or with Slabs, than it will to the average Redis user. Because this is kind of an unusual use case, right? I mean, with Redis, most often you've got caching or you've got some sort of front end, tally, or like with voting, or some basic processing, that is either designed to live closer to the edge, or to give you, even before there was like GraphQL. I know a lot of people who would use Redis to store things that have been denormalized. You've got a dozen queries to a database that come around a user, their preferences, their associations, and so forth, and it all comes and gets put in the front end Redis, which is more than just a cache. It's kind of a denormalized front end data store. But anyway, so lots of common use cases for Redis, designed to speed things up. And I think it's kind of funny, if not ironic, in an Alanis Morissette way, that what I'm trying to do is to slow things down to avoid collisions, and using Redis for that, when it's just kind of the opposite of what Redis is best used for. Anyway, so to create a list, I just pushed active sessions onto the list, and I have session ID 1, 2, 3. Just realized I've got this clicker. There we go. Now I don't have to stand in my computer. So I add some sessions, and you can see each time it returns 1, 2, 3. So I have 3 active sessions. And then when I want to remove one, I remove session 1, 2, 4 in this case. It says 1 session was removed. So when I do LREM active sessions, that 1, for those who don't know, is how many. So how many sessions that, or how many entries to this list that match session 1, 2, 4 do I want to remove? I want to remove just 1, because in theory, these session IDs are unique. And then I do get length, len, on active sessions, and it returns there's 2 active sessions left. And then lastly, I can get a range to see what's available. I can do 0 to -1 meaning the last session. So this shows me all sessions available, 1, 2, 3, and 1, 2, 5. And then lastly, I mentioned you can do some cleanup. If for some reason your list gets untidy, you can drop everything outside the range. Since I've got 100 available sessions, I put 0 and 99, and it'll kill everything else. That's all fine and good, but I decided that was easy. Let's go to the next level, and this is really the part that that the users needed, to create a queue of pending tests, so that you don't have to keep anything going. All the tests, whether it's run by a tester, a developer kicks it off on their local IDE, it's run through a continuous integration server across different teams. What it does is now, instead of starting the tests immediately, it just pushes them onto the queue. And a queue is a simple data structure. It's a linked list, so it's implemented just using the list. And it's first in, first out. So you push it onto the list and you pop it off the list, like a train going through a tunnel. The first car, or rather, like cars going through a tunnel, a train always moves in the same order. But if you have a bunch of cars going through a tunnel, if the red one goes in first and the silver one next and the black one next, whatever, they're going to come out of the tunnel in the same order: red, silver, black. That's a queue. A stack is similar to a queue, except it's like a container. You push things down onto the stack. And so the first one in is at the bottom of the container. The last one in is at the top. And with a stack, you can you then pop off the top. So like a memory heap is a stack, or wait, memory stack. Anyway, but queues and stacks are related. With Redis, you can do either one just as easily, depending on whether you do L push, which is left push, or right push. And my favorite part of this conference was when on the first day, the training day, Salvatore was up here, and even he forgot whether it's L push, R pop, or R pop, L push. It's kind of arbitrary, but the atomic command to push off of one queue and onto another is R push, L pop, meaning you push from the right, I think I might have this wrong. Anyway, he got it wrong too. And instead of looking at the documentation, he brought up the source code and he's like, pound define. Okay, that's the right one. But the idea is that you can go from one list to another in an atomic way. And that's important because I've got this pending queue that's going to go to the active sessions list. So let's see, here we go. Theoretically, this is cut and pasted from an actual session. So I should have it right. So I push something onto the list and of requested sessions. But because I don't have a real session ID, Slabs doesn't know about my session ID. I call it requested session, and this 126 is just a made up number to keep track. You could hash it or whatever. You'll see what it's used for later. And it says there's one, it pushed one. Now I push another one, so 127 is the next test going on to the queue. So now there's 2 in the queue. You can see the response. And then I pop one off the list and requested 126. The first one entered comes off like a train through the tunnel. And then you've got L push active session. So in other words, I pop it off of the pending sessions or requested sessions, and then I push it onto the active sessions after I've established my session ID. Let me look at my old slide. Yep, this is wrong on the slide. This is right here. So R pop, L push. Pop it off of the right side of the first list, and then push it onto the left side of the second list. So I guess the justification for this, it's arbitrary, but in English and probably more specifically in Italian, you read left to right. So think of lists as moving from left to right, although you could do it either way. And then, in this case, the atomic operation pushes the fake session ID, requested 127, onto the active sessions list. And then the next step is to set the real session ID into the active sessions. Now, the size will be correct of active sessions, whether I have the correct session ID or not. I don't have to put the session IDs on there, but it does make it convenient for accounting and especially cleanup when I want to find out, if something happened and some sessions aren't removed from the list and it's looking like my active sessions lists and my pending sessions queue are getting blocked up with stale information. Apart from trimming it, I can go through and remove a particular session. If I find out through my accounting that that test is actually done. So the problem here is that setting that active session ID, you can't tell in a list what or where a value is in that list. It's just a linked list without traversing the list. I'm assuming here that when I do the L set active session 0, that it's the first item on the list. But if someone else adds an item to the active sessions list, then I'm going to screw up and change their session ID. So you need to use a transaction. And I was afraid of transactions at first, but it turned out to be pretty easy. You just type multi at the start, or you call the multi method, which then queues up all your additional sessions. And there was a good session yesterday about atomicity, I think by Thomas Hunt. He talked about how things like pipelining looks like it's doing everything atomically, but it's not. Anyway, so you've got to have a multi. So in this case, I remove one from the active sessions, which this doesn't have to be part of it, but for illustration purposes, it is. You don't have to remove a completed session that, before adding another one. But in this case, I remove the active session that's already completed. I then do the atomic pop push from the requested sessions to the active sessions. And you can see those commands are queued. They haven't been executed yet. And then I set, this is the part, so I push it onto the list, and then I set it after I get the real session ID, and then I execute it. And you can see the result after that is then requested 128 is the one that's affected. And I can check my first session, in this case, because no one else is doing it, is now called session 128. All right, so there's one more piece of the puzzle. I've got to let the client know when he can kick off the session. My app is just a ledger. Literally, it's just keeping track of the tests. It's not starting and stopping them. And part of that's the limitation of Selenium. Now, some Selenium clients, like the Python client, can take a Selenium session ID and run with it with a new session. Others, like Java, can't. It's really an implementation limitation than a practical limitation. But anyway, for those who can't just grab a session ID and pass it around to start or to hijack tests, I use PubSub. The idea being that you just publish when a requested session is now available to be active. And then the client who's waiting for their test to start subscribes. Now, rather than having everyone poll regularly to see what's going on, or to see how many sessions are available, you just have a single worker doing the publishing and the monitoring, and it avoids the need for constant. So here we go, the PubSub commands. First, the client listens. It subscribes to sessions available. This is like the DMV. You take your ticket from the little red tongue dispenser, and then boom, the light comes on and it says now serving B23, or in this case, now serving requested 131. You start your session, you, the second part here is the client seeing what the worker publishes. This is actually two different instances, right? You've got the worker and the client. I just put them on the same screen for ease of display. So the client gets the notice and then kicks off their test and then updates the session. All right. So that's good, but there's another catch in here that my list of active sessions somehow could theoretically have a duplicate ID put in there, which is going to screw things up. But a set, unlike a list, must have the keys be unique, or the values be unique, I guess. I'm thinking in terms of hash. So I thought, well, we could use a set. But a set can't push or pop. Well, there's spop, but spop just pulls a random one from the bag. It's like reaching into a bag. Number B371. Yeah, it's like a bingo ball. So spop doesn't do what I want, but then that's okay. My active sessions, because tests run in different times, the active sessions isn't a tunnel. It's a whole bunch of, I don't know, penguins jumping into the ocean, and when they catch a fish, they come out at different times. So it's okay. So I have a set for my active sessions because when they get off, it doesn't matter. And I still have a list as a queue for my pending sessions. That works. It required a little bit more work because you can't just push onto a set. You can't, there's no rpop L push to a set. Anyway, that would be a cool feature. But you can move it not just from the active session, but now you can have a set of active tests and a set of complete tests and a set of errored tests. And you can use, I don't have the command here, so I don't remember. But there's a command to move it from one to another. I think it's smove, now that I think about it. And you can also group test. So for instance, I can find a group of all completed tests and all errored tests, meaning all tests that have finished, whether they've succeeded or failed. Or I can grab past tests and failed tests, or whatever other group of tests I want to use. And lastly, I can sort the tests back into a list, an ordered list based on either numeric or alpha values. So here's the Redis CLI equivalent of that. sadd active sessions, it looks just the same. Instead of lpush, sadd. And I add the duplicate session, it returns 0, meaning it did not add one. It failed to add a duplicate, and it didn't complain about it. scard is for set cardinality. It tells you how many sessions you have, so it's like len, 1 in this case. smove is the command, so I can move from active sessions to completed sessions. This session 1, 2, 3. And it shows how many move, 1. And then I can add or move to errored sessions, session 1, 2, 4. And then I can combine my completed and my errored sessions with a union. I can also use an intersection to combine those that are in either, or rather that are in both. Or sdiff will create a new set from a set, or from multiple sets of all the elements that are not shared by either. Again, CS 101 data types. I love how Redis implements this. I think it'd be really fun to have like a tutorial, because that was really a struggle for me when I started college, is understanding linked lists and sets, and you know what an intersection is, and all these math terms that describe groups. But with Redis, it's really easy to see. So I think there'd be a cool CS 101 data types course on using Redis that illustrates that. So the next thing is I want to retry error tests, or at least a certain category of tests that have errors that didn't start or that failed for a certain reason that I know I want to retry. So I get my error tests, and I can sort my error sessions, in this case alphabetically, and then store them in the retry queue. The retry queue is going to look just like my requested test queue. I could actually push them back onto that same queue if I wanted to do that. But in this case, I want to do the retry queue out of phase. And then you can see that while at first the sessions in the errored sessions set are in random order, that when they've been sorted, they're now in alphanumeric order in the retry queue or list. Okay, so that's pretty good. Next thing is, what if I have all my tests? You know, say I'm a big organization, I've got 1,000 concurrent sessions, and I've got 10,000 regression tests in the queue. But there's a big production bug we've got to fix. We need to run some basic smoke tests to get it out there immediately. We don't want to wait hours for these thousands of tests to complete, maybe. We need to get right to the top of the queue. Sorted sets are the answer for that. So Z sets are sorted sets. Allow you to include a score. Other than that, it's like a set, but it's also, because of the score, you can rank it. It's like a list. You can push and pop in a logical method, you know, by the score. So you get unique keys like a set, and you get push and pop like a list. I thought this is perfect, and then I learned, was it yesterday or Monday day, that sorted sets are actually really expensive. Now, we've never really pushed the boundaries of scalability with this. You know, we're talking thousands or at most 10,000s of concurrent sessions. So it's not really a big thing. Maybe if this was implemented by Slabs and all their users were using it at once, then there'd be a scalability issue. But be aware that sorted sets are quite expensive in terms of operation and memory and storage. But in this case, it turns out to make everything easier. And now I can have sorted sets that I can push and pop off of. For instance, I can push off of my error tests in a mannered way back to my main priority queue. And now my priority queue, normally I give everything a score of 1. Everything goes in easily. But when things have higher priority, I can push them up. Or if team A is favored over team B, they can have a score of 2 or something. Anyway, I'm open to things like bribery to allow one person to get their test done before another. And like a list, a Z set doesn't care. You can zpop max or zpop min, left, right, top, bottom. It doesn't matter. Redis is flexible, although you need to make sure you don't mix them up like I did earlier in my slide. Maybe I did that just to illustrate a point. No, I've been through this 100 times and I didn't catch it. Anyway, the sorted set commands, zadd, priority queue, priority of 1, session 1. And then I add test 2, session 2, with a priority of 2. So now, which one's going to execute first if I do zpop max? Number 2. No, max is the highest score. But if I did zpop min, then 1 would go first. So now, because session 1 was my session and session 2 was yours, I'm going to bump my priority by 2. So my new priority, as you see here, is 3 with z increment by. And now you see my tests. I do z range priority queue 0 to -1, so all elements with scores. That's another nice thing. Z range, there's no set, or there's no S range, I don't think. But you can, anyway. But I can do with scores. So I see session 2 has a score of 2. Session 1 has a score of 3. Session 1 wins the match. When I zpop max from the priority queue, session 1 goes off that queue into the active sessions. And I get to go home before you. Kind of the last thing to do is to capture the test data. There's a lot of metadata around test as well as the test steps. The main things I want to capture are the platform that the test is running on. So the browser, the version of the browser, the operating system, the mobile device it's using, the test name, of course, and any associated tags with the test for the build, whether it's a regression test, and the test status when it passed or failed, and maybe things like time, who executed it, that sort of thing. So here's the operations, and I'm running low on time, so I'll try and zip through this. hset adds a session. You can see here, these are the values I added. I can check if it exists, or I can check if a particular value exists here. Status. I don't even use this. So returns 0, status does not exist. So I go ahead and set the status. This test passed. And then I can get the status. That's the great thing about a hash, is you can get an individual value. If I threw all this into a blob, then like a JSON blob, then I couldn't get that. But I can get all the results or a single result. So that's a hash. That's where I'm currently at, that I'm storing test information in a hash. There's some challenges, though, to store complex data, like hierarchical data. One thing I can do, JSON, right? I can store my JSON as a string. Jumping ahead, of course, now we have Redis JSON, which I think must have just been renamed from ReJSON in the last couple months, or else I was reading old documentation. Or you can do multi-part keys, such as foo.bar equals baz or whatever. Or you can use relationships. I can use that session ID for different collections, whether it's a set or a hash, whatever. You know, if that session ID 123 is the same session and I know that, there's a little bit of logic built in that can do that. And lastly, I can use Redis Search to do some more complex queries, full test search and stuff like that. So Redis JSON, it's a module. You can compile it in. It's actually pretty easy, easier than trying to put Apache modules in, but it uses the same sort of syntax, load module and then a path. Or Redis Labs, Redis Enterprise has it built in for paying, and it allows you to store. So here's some simple JSON commands. You set JSON, and you have to kind of wrap it in a string, and then you get it, and it returns it kind of as an escaped quoted thing. All right, since I'm running out of time, I'm kind of bursting through here. Redis Search, again, it's a module, can be compiled in. It allows for full text search, but it also allows for things like numeric search, or, as I learned yesterday, tags that you can group by tags. So for instance, the tag I'm thinking of is test status. And it allows you to throw in somewhat unstructured data and mess with it later. Things like test steps, log files, error messages. So here's, I'm creating a schema in Redis Search, ft create test results, schema, and then my fields, name is a text field, platform is a text field, browser is a text field, version, and then execution time is numeric. It's going to be an integer, how many seconds it took this test to execute, and then status, passed or failed, is a tag. And then I add an element, nothing surprising there. And then I can search for anything that has login. So it's going to return this that says login test in this case. I could search for anything that has Chrome or whatever. That's the great thing about full text search. I can also search for specific keys. In this case, I'm going to search for the status tag, whether it's passed or complete. In this case, returns this one that's passed. All right. So looking forwards, I'm hoping to be able to gather more information on this to be able to predict when tests fail, why they fail from groupings. I heard someone say recently, and I really like this, that when people say AI, what they really often need is just a group by clause in a SQL query. But of course, Redis isn't SQL. But anyway, you can group things by all sorts of values or whatever. And you don't always know what they're going to be in advance. So especially if your data is semi-structured, not SQL, then SQL group by clause isn't going to do it. Anyway, and then using machine learning to look over those test results to say, hey, this particular test set tends to have a certain number of more failures on Safari for this particular feature or whatever, feature group. And I'm hoping to be able to use tools to do that, but that's kind of beyond the scope of my first thing. And that's it. I've got 2 minutes left, so I'll go ahead and ask some questions, but I wanted to show, here's a picture of my RV and my yurt, and more especially in the upper left-hand corner is my son Mikey. Today is his birthday. He just turned 4. All right, thank you, everyone.